This is a how-to video on the chi-squared test of independence. Before we talk about the test of independence, though, I want to talk a little bit about chi-squared distributions. Chi-squared distributions are used to test information collected on categorical variables that couldn't be tested with a normal distribution. There is a formula for chi-squared, as you can see, but you won't need it for the AP Stat exam. Just use your calculator. It will be easier and quicker. A unique characteristic of a chi-squared distribution is that as the degrees of the distribution decrease, the degrees of freedom, of course, the distribution will become more skewed. As you can see here, the black curve represents a distribution with only 1 degree of freedom, but the tealish green curve represents a distribution with 20 degrees of freedom. As you can see, the distribution with 20 degrees of freedom looks more normal than the distribution with only 1 degree of freedom. A chi-square test of independence is used to compare the relationship between two categorical variables from the same population. So when you're taking your test, be sure to look for keywords such as independence, dependence, relationship, and association. And also, if you are given a two-way table of observed values, you know that you should use the chi-squared test of independence. There are 6 steps. First, if you are performing this test for an FRQ, make sure you write the test name. Second, write both your hypotheses, the null and the alternate, in full sentences. 3, calculate and write your expected values, your chi-squared, p-value, and your degrees of freedom. 4, make sure you state your conditions. 5, write alpha and compare the p-value to your alpha. And 6, write the conclusion in the context of the problem. So let's solve a problem. This kind of problem would typically be given on an FRQ. So 3 alert nurses at the Veterans Affairs Medical Center in Northampton, Massachusetts noticed an unusually high number of deaths and missing supplies at times when another nurse, Kristen Gilbert, was working. They reported their concerns and an investigation followed. When seeking a grand jury indictment, prosecutors provided a key piece of evidence consisting of a two-way table showing the number of shifts with deaths when Gilbert was working. Test a claim that Gilbert was on duty for a shift is independent of whether a patient died during the shift. Now, I know that the problem is asking for whether the two variables are independent, and we are given a two-way table of observed values, so we know we should perform a chi-squared test of independence. So step 1, of course, if this is an FRQ, just name the test that you will be doing, the chi-squared test of independence. Step 2, write your hypotheses in complete sentences. For your null hypothesis, make sure that you write both the variables are independent. And for your alternate hypothesis, make sure that you write the two variables are not independent. Do not write that they're dependent, because you're only testing for independence between the two variables. So in this case, the death of a patient is independent of Gilbert being on duty for a shift. That would be your null hypothesis. And the death of a patient is not independent of Gilbert being on duty for a shift. That would be your alternate hypothesis. Step 2, calculate and write your expected values. Plug in your two-way table of the given observed values as matrix A into your calculator. Once you do that, go to Stat, Tests, select choice C, which is a chi-squared test, and then for your observed, you're going to put the matrix in which you put in all your observed values, which was matrix A, and then for expected, you can make that matrix B. Once you do that, hit calculate. You should get your chi-squared, which is equal to 86.481, your p-value, which is equal to 1.411 times 10 to the negative 20th, and your degrees of freedom, which is just your number of rows minus 1 times number of columns minus 1, and that should equal 1. And for my expected values, I made a two-way table again, and I labeled just like the two-way table for observed values, but I labeled this expected values. So as we know, we need to state conditions as step 4. You need to know whether or not the data was collected using a simple random sample. Usually it will say this in the problem itself. It will be pretty clear whether or not an SRS was used. An SRS was used in this case. Expected values should all be greater than or equal to 5. Well, yeah, they are. That's good. And each outcome can be classified into one cell. That is also true. All our conditions were met, so we can go on to step 5. Step 5 is write your alpha and compare your p-value to alpha. So since we weren't given an alpha in the problem, it is best to just use alpha equals 0.05. So it's not too low, it's not too high, like it would be if you use 0.01 or 0.1. So if you compare your p-value to your alpha, you can see that p-value is actually less than your alpha. So we can reject our null hypothesis, leading us to step 6. We will write our conclusion in context of the problem. So we would say, we can reject our null hypothesis because there is enough significant data to say that the death of a patient is not independent of Gilbert being on duty for a shift. All right. Some things to remember are that you want to write both your hypotheses in complete sentences. Your alternate hypothesis will only say that the two variables are not independent, and it will never say that they are dependent. If your significance level isn't given in the problem, make sure to use alpha equals 0.05. Your degrees of freedom is your number of rows minus 1 times the number of columns minus 1. Now, this is another example problem, but this would be on the multiple choice part of the AP Stat exam. So, let's get ready. A study was done to determine the effectiveness of varying amounts of vitamin C in reducing the number of common colds. A survey of 450 people provided the following information. And I have my observed value here of my daily amount of vitamin C taken and how much the amount of colds that each person got. So the question asks, is there evidence of a relationship between catching a cold and taking vitamin C? Well, before I get started, I'm looking through these answer choices and I can see that I have to compare my p-value to multiple different significance levels. So I will have to compare my p-value to all 3 of the significance levels to get my answer. So before I even read the rest of the answer choices, I'm going to complete my test of independence and then I will come back. And obviously I will do a chi-squared test of independence because it says relationship in the problem and I'm given my two-way table. So my chi-squared for this was 1.987, a p-value of 0.37, degrees of freedom of 2, and my expected values, I made a two-way table and I labeled it expected values the same way my observed values two-way table was. I listed all my conditions and stated whether or not they were met, and they all were. Now, as I said before, I had to compare my p-value to my three significance levels to 0.01, 0.05, and 0.10. And my p-value is greater than all three, so I would have to fail to reject my null hypothesis at all three levels. So, the answer is E. There is not sufficient evidence at the 10% level of a relationship between taking vitamin C and catching fewer colds. It wasn't A because correlation does not equal causation, and we only knew that the two were not dependent. So there was really no relationship established because we weren't checking for dependence. Dependence would mean that there was some kind of relationship. Right now, we only know that they're not independent. It wasn't B because the chi-squared test of independence only tests whether the two variables are independent or not independent, and not if there is a causation of one variable due to the other. So again, similar to A. It wasn't C because there isn't significant evidence at 1% because our p-value was greater than alpha. And it wasn't D because there wasn't significant evidence at 10% and 1% because p-value is greater than both. And using that same explanation, we can now pick E as our answer because there isn't sufficient evidence at 10% because our p-value is greater than both.